Lesson 2, graphing repeated addition versus repeated multiplication. Compare box A with box B. In box A, we have repeated addition. In box B, we have repeated multiplication. So in box A, here we have 0 plus 0 equals 0, 1 plus 1 equals 2, 2 plus 2 equals 4, 3 plus 3 equals 6, and so on. Now let's try box B. Here, 0 times 0 equals 0, 1 times 1 equals 1, 2 times 2 equals 4, and 3 times 3 equals 9. Now let's work on the graph. We're going to show repeated addition first. On this chart, we're going to show repeated addition using the addends of 0, 1, 2, 3, and so on. So 0 plus 0 equals 0, 1 plus 1 equals 2, 2 plus 2 equals 4, 3 plus 3 is 6, 4 plus 4 equals 8, 5 plus 5 is 10, 6 plus 6 equals 12, and 7 plus 7 equals 14. Now, use a straight edge to connect these points, and your graph will look like this. So this shows repeated addition, and this represents box A. Now let's show repeated multiplication. We're going to show repeated multiplication using the factors of 0, 1, 2, 3, and so on. So 0 times 0 equals 0, 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, and finally 7 times 7 equals 49. And notice that you won't be able to connect them using a straight edge because it'll be a curve, and your graph should look like this. So this represents repeated multiplication, and this represents box B. Let's complete the statements to the right. With repeated multiplication, numbers can become very big, just like you see here, or very small, which we'll see later, very quickly. Here's the next sentence. Use an exponent as a shortcut for writing repeated multiplication. Here's the next section. Simplify each repeated multiplication problem below using exponents. So here we have 8 to the third power, 3 to the fifth power, and 5 to the fifth power. Next section. Below are the squares that you've already memorized. Simplify using exponents. So 5 times 5 is 5 to the second power. 6 times 6 is 6 to the second power. 7 times 7 is 7 to the second power. And 8 times 8 is 8 to the second power. Now let's figure out why they're called squares. Here it says, a number or unit raised to the second power has been squared. So take a look at this large square here. And if I know this length is 2 meters, I know this length is 2 meters as well. 2 times 2 equals 4, and meters times meters equals meters to the second power. This can also be pronounced as meters squared because it makes square meters. So this length is 1 meter, but this area is 1 square meter. Here's 2 square meters, 3 square meters, and 4 square meters. And that's why meters to the second power can be pronounced as meters squared. Here, 5 to the second power can be pronounced as 5 squared, because when you multiply something by itself, it makes a square, just like this. Here's 6 squared, 7 squared, and 8 squared.